What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to figure out the number of terms in expansion of binomial. So in some question they ask you how many numbers we have or how many terms we have in the expanded form. So before I start some examples, I need to go through some notes. Note number 1. The integer n is called the index of the binomial. For example, if you have x plus y to the power of 6, the index is 6. The number of terms in the expansion of x plus a to the power of n is n plus 1. So whenever the index is n, the number of terms is going to be n plus 1. So it's super easy. In the expansion of x plus a to the power of n, the power of x goes on decreasing by 1. And that of a goes on increasing by 1. So it means that the first term is decreasing and the exponent of the second term is increasing. So that the sum of powers of x and a is on any term is n. So for any term on the expanded form, if you add the exponents, you're going to end up having something equal to n. Then since NCR equals to NCn minus r, we can say NC0 equals to NCn or NC1 equals to NCn minus 1. So what does that mean? I need to show you the Pascal triangle, if I can find it. There you go. So here, Pascal triangle. As you see here, we have one for each side of different terms. So this one is for n is 1, n2, n3, n4, n5, n6, n7, n8, and so on. N is the index. So as you see here on the side is 1, 1, 1, 1, 1, 1. And the second one from both sides is, for example, 3. For here, 4, 5, 6, 7, and 8. And then something like that for 10, 15, 21, or 35, 8 or 28, 56. As you see here, for both sides is going to be the same. So we can say NCR equals to NCn minus 1. Which makes sense because if you go back to the formula here, that's n factorial divided by n minus r factorial times r factorial. So this one is going to change for these two numbers. So the answer is going to be the same in total. So note 5. Binomial coefficient of r plus 1th term is NCR. That's very important. We're going to have some examples later on in future. T of r plus 1, it means that r plus 1th term is NCR times a to the power of n minus 1 times x to the power of r in the expansion of a plus x to the power of n. These three notes are important. Number of terms in the expansion of x plus a to the power of n plus x minus a to the power of n is n over 2 plus 1 when n is even number. Number of terms is x plus a to the power of n minus x minus a to the power of n is n over 2 when n is even. Number of terms when we are talking about x plus a to the power of n plus or minus x minus a to the power of n is going to be n plus 1 divided by 2 where n is odd number. So that's how we find out the total number of terms beside the second note. So note 2, note 7, note 8, note 10 is going to give you the total number of terms. Let's have some examples now. So I provided here 6 different examples. So let's go through one by one. So the first one, it says, the question is find the number of terms in the expansion of the following. So the first one, it says 5x plus 2 to the power of 8. How many terms we have? So if I go back in here, it says the number of terms in the expansion of x plus 8 to the power of n is n plus 1. So in this case, index is 8. So we have 8 plus 1. We have 9 terms in this expansion. What about next one? Next one is x minus 2 over x squared to the power of 11. So in this case, the index is 11. So the number of terms is going to be one more. So 11 plus 1, we have 12 terms. That's how we find out. What about the next one? Next one is 1 minus 2x plus x squared to the power of 9. So you might say we have 10 terms because 9 plus 1 is 10. But here, we don't have binomial. We need to make it binomial. So we have quadratic function. We need to convert it to binomial. That's going to be like 1 minus x to the power of 2, then to the power of 9. So that's going to be 1 minus x to the power of 18. So how many terms we have? 18 plus 1 is going to be 19. So 19 terms. That's how we find it. Next one. How many terms we have here? 1 plus 5x to the power of 7 plus 1 minus 5x to the power of 7. So here we have plus in between and we have odd number as index. So if you go back in here, we have odd number. Doesn't matter if you have plus or minus in between. The number of terms is going to be n plus 1 divided by 2. So we have 7 plus 1 divided by 2, 8 over 2. We're going to have 4 terms. Next one, 3x minus 2y to the power of 12 plus 3x plus 2y to the power of 12. So we have plus in between and the index is even number. So if we go back to this note 7, when we have x plus 8 to the power of n plus x minus 8 to the power of n, if n is even number, the number of terms is going to be n over 2 plus 1. So that's going to be 12 divided by 2 plus 1, which will be 6 plus 1. So we have 7 terms in total. Next one. X plus 2y to the power of 8 minus x minus 2y to the power of 8. How do you find it? Again, the exponent or the index is even number, and we have negative in between. So we have select x plus 8 to the power of n minus x minus 8 to the power of n. So since n is even number, it's going to be n divided by 2. So we have 8 divided by 2. We're going to have 4 terms in. So total. So basically, that's how we find out the number of terms in binomial theorem. I hope you enjoyed this video. Please leave me a comment if you have any question. And please don't forget to subscribe this channel and recommend it to your friends and colleagues. Thank you for watching and have a great day.